In calculus, we often use the limit definition of a derivative, and we need to evaluate such a limit. To do so, we must simplify our function. For example, suppose we were given the following limit. To evaluate a limit like this, we need to go ahead and simplify the function on the inside. An example like this is where we would use our addition and subtraction formulas from trigonometry. So let's suppose we already had our addition formula. Well, what that means is we could replace this sine of x plus h with the following equation. Then once here, we could simplify again this function over here by using factoring, and this would simplify to be the following. And then simplifying this one last time, we'd be able to rewrite this as a limit that we could go ahead and evaluate. So these formulas are important because they allow us to evaluate limits, and in this particular example, it allowed us to find the derivative of sine x. Before we state the formulas, let's go ahead and derive where these formulas come from. We'll particularly be looking at formulas for cosine. To find these formulas, we'll be looking at the following picture, and this picture is the unit circle at center 0, 0. And suppose we're given the following 4 points that lie on the unit circle. We have P0, which lays on the x-axis. We'll have Q1, which lays on the unit circle and forms an angle of t. We have the point P1, which is s angles away from Q, which means that the angle of P1 is going to be s plus t. And finally, we have the point Q0, which has angle s minus 1. Negative s. Since all these points lie on the unit circle, the x component is going to be equal to cosine of whatever angle we're looking at. So in this case, we'll just say theta, and the y component is going to be equal to y sine theta. Then Q1 is going to be given by cosine of t sine of t. Q0 is going to be given by cosine of negative s, comma sine of negative s. P1 is given by cosine of s plus t, sine of s plus t. And P0 is given by 1, 0. Now, using geometry, what we can show is that the distances between P0 and P1 and Q0 and Q1 are equal to each other. And the distance between these two different sets of points are shown in the picture by a white line and a yellow line connecting the respective points. So if we calculated the distance between Q1 and Q0, this is going to be equal to the distance between P1 and P0. And we can do that using our distance formula. Doing this, we'll get the following equation. Now let's go ahead and square both sides and then simplify. So we obtain the following, and we notice that we have our cosine squared here and our sine squared here with the same argument. So these two things added together give us 1. And by a similar argument, our cosine squared t and our sine squared t, along with our cosine squared s and our sine squared s, will also reduce and give us 1. So let's simplify this again, and we'll get the following. Now subtract 2 from both sides, then also divide negative 2 on both sides, and we'll get the following. And this is what we call the addition formula for cosine. Let's go ahead and look at the subtraction formula for cosine. So we have cosine of, we want an s minus t, and we can rewrite this as cosine of s plus a negative t. Applying the addition formula for cosine, we get that this is going to be equal to cosine of s times cosine of negative t minus sine of s times sine of negative t. And we know that cosine is an even function, sine is an odd function, which means that cosine of a negative x is equal to just cosine of x, and sine of negative x is equal to a negative sine of x. So we can go ahead and rewrite our formula by simplifying these two terms, and we'll get that this is going to be equal to cosine of s times cosine of t plus sine of s times sine of t. and this is going to be our subtraction formula. So now let's just go ahead and list all the addition and subtraction formulas for sine, cosine, and tan. The addition and subtraction formula for sine are given by the following two, and the formulas for cosine are given by the following, which we just derived. And then the formulas for tangent are given by the following. Where let me go ahead and note that these in fact are quotients.